Good morning, everybody. Happy Friday. Wow, it's awesome to see that it's everything. It's getting full up to the end. That's awesome for Friday. Um, I was walking along the halls yesterday, and it was pretty amazing to see the number of people that were visiting booths. And as I was, engaging with people, it was just, people exchanging cards. And I was wondering, like, hey, I don't have any cards with me. So I was going to do an exercise with you all. How many of you actually do not have a LinkedIn application on your phone? Wow, zero. Hey, I think we got to work on you. Anyway, so I was thinking, like, at these conferences is an awesome place where people can connect, right? And one of the features that we have in our phone is kind of a near finder feature. Like if you go in your connections, I think it's on the top, so you can find people nearby you. And I encourage you all to turn that on and see if as you walk around the hallways and or someone sitting next to you, you'll actually get connected. Because sometimes you walk around and you say, hey, that person, I forgot his her name. So anyway, just wanted to plug it out there. So that's also part of, why LinkedIn is what it is today. Our vision is to create economic opportunity for every member of the global workforce. And you all are part of this great economic opportunity. Now, at LinkedIn has a number of products in its platform, but in its core, we are actually a very deeply connected graph. And it's a very complicated computational problem to connect this graph together and divide them across the multiple geographies where we have our infrastructure. So in order for us to serve the best member experience that we can provide, we have to build and scale a really amazing infrastructure across multiple data centers, multiple POPs, a huge backbone. So all of those things really compel us to stay on top of creating the most scalable and robust and efficient infrastructure as possible. So we have over 500 million members in the world to actually make sure that they have the best rich experience. And we sign up over 2 users a second, which is an enormous feat to sort of just keep infrastructure up. So this is actually why we are going to talk about our story about why hardware and openness and is all super important to us. So we actually joined OCP through the Sonic effort. A lot of folks in my network team were looking at ways to get more visibility into the switch, build applications top of it, and we found that Sonic was the right fit for us, and we collaborated very heavily with Microsoft, and then also with the overall Sonic community at OCP since 2017, and it's been a tremendous amount of work there. You saw Dave Maltz yesterday talk about our adoption and how great it has become, and we are very excited that this is now the de facto switch operating system in all of our data centers. And then following on to that, as we are building more and thinking more about open hardware, we actually joined OCP as an official member in May 2018 as platinum members, and we're super excited about that. And adding more to that, we are actually very, very excited now to announce today that we are opening our Open19 specification and contributing it to OCP. You've all heard us working on Open19 platform for a while. There's been a lot of blog posts, but we've sort of been maturing the whole aspect of it, and now we feel that it's actually, we want a much, much broader adoption. We wanted more people to come in and help us solve these complicated problems that we find as we are scaling and building hardware. So it's really awesome and fantastic that we are trying to have this sort of community come together. And we are actually very honored to be part of OCP and look forward to sort of further engineering groups working together to solve this problem as we're being open together. So let's talk about why we did Open19. I'm sure that's sort of the fundamental question that most of engineers ask. Well, like every engineering problem, we ran into a lot of constraints when we were building our data center. So a few years back, one of the things about LinkedIn is that we are mid-sized. Our data center is a little bit more mid-sized than sort of the larger scale. We don't have the luxury of endless amounts of land, so we were always constrained with some space and making sure that we don't run out of space, or we don't run out of power. Sometimes when we run out of space, you have too much power, and vice versa. So our teams really strategically thought about, hey, in order to circumvent this problem, we're really going to dense up our racks. Let's figure out how to dense up as much as possible and be as efficient as possible. So we actually, one of our requirements inside our data center is let's try to ramp up to 96 servers per rack, which was quite a difficult engineering feat to make sure that we don't blow out the powers. We are efficient in serving our power. So that was sort of one of our fundamental tenets. And then we said, well, this thing should actually work on a standard 19-inch rack. We should not create any other type of standard, because we want to be able to buy things off the street, off the market, and we don't want to create any sort of too many custom solutions. And 19-inch rack was this de facto standard in every data center. So we said, well, let's make sure that that's part of it. And then we also, the core fundamental principles we had was that this is also a disaggregation play. And that's why we want to put all of this together and say this is the sort of the philosophy of why we are creating Open19 technology. So let's dive a little bit deep into this. There's actually an engineering workshop later where my engineers will go into much more deeper depth, but I'll just sort of at a high level talk about what Open19 technology is. So at one of the cores of it, from the outside, the brick cage is basically one of the very, very important tenets of Open19 technology. This cage comes in 8 RU and 12 RU, and basically it's a passive cage which enables you to put in various configurations, kind of like a Lego building block of servers, we call it. So you can say, hey, I want a half-width server, and then I want to also mix that in the same rack with a full width and a double wide, double height, double wide. And so all of these things, we wanted to make sure that folks could have the flexibility to decide which configuration that they wanted. Also, part of this specification, we were looking at that as we talked to a lot of the vendors out there, we found out that the servers only take 12-volt supply. So we wanted to create efficiency in the rack by removing the power supply from the individual servers. So we built a power shelf unit, which is part of the Open19 specification, and that sits on the rack. It takes a regular feed of the 19.2 kilowatt, which is pretty standard in the data centers, and it's got about 6 modules based in it, and it has a BMC, a Linux-based BMC to manage each of those servers in a very isolated environment from each other. The other thing that we felt was that should be part of this specification is a white box network switch. Now, this is an optional module, but if you want to adopt our version, we actually have opened that up in this specification. And it is a 3.2 terabit chipset. And it's running actually a full Sonic platform on top of it. So it's totally usable today with the Sonic platform. And it also supports OpenBMC for ease of management. This is sort of like the standard aspect from the view from the front. Now let's sort of turn the rack around and look at it from the back. And what you'll find here is amazing: no cables. One of the things that our data center engineers were really looking forward to is like, hey, as we build these massive pods, this sort of like as we scale out our data centers, cabling management is a huge nightmare. So they spend a lot of time thinking about how do we actually get rid of cables. So when the working group that we had at LinkedIn looked at this, they said, just remove the concept of cable. Let's come up with something that is very easy to use and can speed up our time of integration. So we used a blind mate technology to have just 2 feeds of power cables. The power cables, as I was mentioning, the standard data center power feeds are typically 19.2. We can actually split them into 2.9.6 cables. One thing that we do at LinkedIn is we kind of have this leaf concept. So you can take 48 servers on one leaf and 48 on the other. So you can kind of split your power that way. Wanted that flexibility, but they're built to be rated at 400-watt power cables. So they'll all work for the 19.2. The other thing was that we want to be able to support the 100-gig data cables, and the data cables are also a part of it. Just one moment, I'll actually show you how these cables look like. So here's an example. Thank you. This is actually a data cable, and it is this way is a better view, I think. So this is typically how it looks. It's got blind mate connectivity. It's channelized. So you can actually do, our servers do like 50 gig per server. So these are actually built for more than that. But since the 3.2 terabit switch only supports up to 100, so we split our, we have PSM4 technology that basically splits this into 250 gigs. So, but this is what it typically looks like. Very easy to plug in. No screws needed. No screwdrivers needed inside the data center. This is a power module cable. Sorry, a power cable. And same thing with blind mate. It's very easy just to clip on everything, and the power source comes this way. So thank you very much, David. Just wanted to show you how easy it is to just walk around with those things inside a data center, how easy it is to plug in. I would actually encourage you all to come by a booth and try some rack integration, play around with these cables. I think you'll have a lot of fun. So it's all great when we kind of design things in the lab, but I'm very happy to announce that Open19 is actually live at LinkedIn data centers, in all of our major data centers. We have them installed in multiple pods, and we are slotting in service. So on the left side, you see this is just an example of a pod that's ready to go. The servers have not put, but it gives you a view of like what the cages look like. Very neat, very easy to just go slot in things. And on the right is when we start populating servers. They look pretty much like they don't look any different from when you walk in a data center and see your servers, because the cages at that point are hidden. So again, there are multiple pods of this, or all of our data centers. Now, something interesting happened like about 6 to 8 months ago. Our workloads were increasing. Early on, I talked about how complicated our graph is. So one of the applications that run our graph requires a high memory and high count of CPUs. So what we did was we were looking around for what platform would suit best to enable this type of high memory and high CPU. So we actually found that the Olympus platform was actually the best platform for us. So we decided to adopt the Olympus platform and integrate it into the Open19 platform. And that's actually running production in our data center today and doing really amazing. We took sort of all the goodness of Olympus and combined it with Open19. And I think this is an example of sort of like early on, we're talking about open together. Like, I think this is like an example of that. And also how it can be a force multiplier into sort of enabling the better applications onto the platform. So open together and force multipliers is two great combinations. And if you are interested in seeing this, the picture is exactly the same. It is. You will see blue servers in our booth. That's actually the Olympus platform on top of the Open19. So please feel free to go visit. So there's lots of benefits of Open19 technology. Some benefits we actually find that are very specific to LinkedIn, but we also find that these benefits actually extend to the greater and broader community. So I've also already mentioned how this is very useful for any 19-inch rack, and so that's sort of one of the biggest benefits, is that it can work on any 19-inch standard platform. The biggest thing that we find, and I'm hoping that other people will find, is that the rack integration is super fast. Right? We've found upwards up to 6x faster rack integration, which is because all of that is extremely simple cable cabling that we've sort of managed to build. The other thing is the efficiency. By actually talking to all the vendors, they all say you just need 12-volt input into your server, right? So we took that into consideration, and actually that brought our power consumption down a lot, and we're conserving 96% power here. And of course, cost is also a huge factor for us. Is you'll find that adopting this, you'll build your own cost models. I'm sure you will find a lot of savings too, which is really great. So a lot of people have helped sort of build this. This cannot work with us just doing things in the lab. We've had tremendous amount of help from our technology partners, and you've seen them, and I really want to call them out to say thank you for helping us get this technology out the door, and then even beyond into our data centers in much bigger quantities. So thank you. But also, I'm really, really happy to see that these partners are actually part of the Open19 ecosystem, which is really amazing, and it's fantastic that they all are part of this ecosystem that can help propel Open19 technology forward, and also contribute to sort of developing and making it better. So I'm really thankful to see that the same partners we're working with are part of this Open19 ecosystem. So I thought that actually it would be really nice to give you a little bit of a tour inside our data center and see how this integration works. I've talked about rack integration being really awesome for a while, but why don't we just take a step back and see how it actually works in our data center?
Hi, I'm Brad Peterson, part of LinkedIn's data center engineering team. I'm here in our Oregon data center, home to some of our most innovative technologies, and most recently, Open19. One of our favorite aspects of Open19 is that we can deploy it much faster than standard off-the-shelf hardware. Now let's watch our technicians deploy off-the-shelf hardware and Open19 technology. Thanks for checking out Open19 technology. Until next time, this is Brad Peterson with LinkedIn.
Thank you. Wasn't that an awesome video? So Brad and team will be at the engineering workshop later today, so now you know what Brad looks like, so you can find him. Anyway, they're going to be going deep dive into the technology, so please, I would really encourage you all to go and check out the workshop. So LinkedIn is very committed to OCP. We are really looking forward to being open together, to be actually collaborating, getting our engineering leaders together, our engineering teams, and actually collaborating, coming up with new designs together, and finding those points of leverage, finding those points of optimization. So this is actually a future that I'm really excited about in sort of LinkedIn's next journey into open hardware. The other thing that really is exciting that we're finding is that edge computing is now sort of really taking off. And we didn't realize, but edge computing has a really interesting problem that when you're deploying a lot of infrastructure out on the edge, there isn't the same kind of like a data center facilities around there. Like you don't have even technicians that are close by. So you want to be able to deploy something out there that's sort of more like a set and forget. You don't have to touch it that often. So we find that a lot of people that are now starting to adopt Open19 are actually deploying it on the edge, and we've seen a small number already. And they've the reason is because they want to be able to put these things out there. They don't want to think about cable management. They want this sort of like BMC view into things, so that when they have hundreds or thousands of these around, that it's all just sort of like one unit, and they don't have to think about sending people over to this side. So that's really exciting. I think what we'll end up doing is actually contributing a little bit more as we see how this progresses. We are working on some server solutions, so I think in the next year you'll probably see us contributing a lot more there. Also, we've actually been doing a POC on liquid cooling. It's actually out in our booth. If you're interested, you can see the demo. But this is something that we think is sort of the next sort of generation we want to go tackle the efficiency at. So we're truly excited about this. So I look forward to also contributing this to OCP in the future. Thank you, everyone. It was really an honor to be here and give you this story, and I hope that we can sort of embrace this open together again, and then I look forward to sort of seeing you all either at our booths or at our workshop. Thank you.